So, you should, by the way, kind of have your notes out, so that when we start talking about how we're supposed to match these up, you have something to write on, especially when you're trying to make connections with how to do your exit ticket today. Okay, so what I have here on the left side of the screen, I have a screenshot of your work. I took this from what you all put on Desmos. Notice that the names are like weird, different historical people names. That's because I anonymized it so that I'm not like pointing someone out or like putting unnecessary spotlight on you, because that's not the intention. So that's why the names are changed. But this is your work. This is what some of you produced. So what I have here is I have a little screenshot of some of the work. What I'm going to do is, in my mind as a teacher, I'm looking at this, and even you as a student, when you're looking at other people's work, you want to like sort out the different stuff that's coming up. So I first circled in red all the responses that tried to match up card number 1 right here to card number 4. So I circled those in red, and I'm trying to figure out, what are they trying to say? Why do they match up 1 with 4? So I look at the first response. It says card 4 matches with 1 because it is the standard form of the factored form. So I notice in this one here, it has a lot of like language, like terminology, probably from Algebra 2. They're talking about something called standard and factored form. Maybe some of you remember that language, maybe some of you don't. So let's go ahead and move on to the next card, or the next response. So this person, Martin, here said, I match card 1 with 4 because once you simplify by squaring what's in the parentheses using a sort of multiplication table, you're left with 4x minus 4x plus 1. So this Martin person kind of gave us a detailed explanation of what he did. I'm going to take a look at that response in a second. The last person who matched card 4 with 1 said, they did this because when you solve, it gives you the same thing. So, okay, all of these kind of have the same kind of answer, but they described it in a different way. What I want you to focus on today is, how are we describing the work that we do? So in red here on the right side, I went ahead and put some bullets. I noticed that 3 students who matched 4 and 5, they mentioned either factored form, they mentioned simplifying, and they mentioned something called solving. So that's what I noticed right now so far. And then we'll talk about the purple ones in a second. Right now, I'm just going to look at the ones I circled in red. So I want to figure out exactly how did these students match 4 with 1. And the response that gives me the most information is right here, the one that's Martin. He gives the most information of what he did specifically. It's not enough to say, oh, I simplified, I solved. You want to like give us a detailed explanation of what you did. So I'm going to go ahead and show you how I'm going to try to apply what Martin did to see if he's right? Is it true? Does it work? La la la. So what I'm going to do is I'm going to have to minimize my this right here, and I'm going to pull up, use the knocking. I think that's a package. I think the language here, the multiplication table, is the box method. Maybe some of you remember this from Algebra 2. It's a method of multiplying 2 binomials. Yes, you want to copy this down. Copy this down in your notes right now, because we're about to show you the process on how to match these up. Okay. So the box method, again, it's when you have 2 binomials. And what I mean by that is this right here. You want to rewrite it to this, because that's what it means. It means multiply 2x minus 1 by itself. So first, rewrite. And then we're going to go ahead and do the box method. Is there any way I can make it a little bigger? Like my writing bigger? I mean, I could try like that. I think that's as best as I can do right now. Sorry. Someone mentioned if I can make it bigger. Let me know if that helps, okay, yes, it does help. Okay, so right now, y'all, I'm looking at card number 1. I rewrote it like this, and I'm going to be using the box method to multiply this out and see if it's true what Martin said over here, that if we multiply that out, we'll get that expression to matches to card 4. Okay, so this is a box method, everyone. You're going to draw a little box like this. And for the top one, I'm going to put 2x minus 1. Over here on the side, 2x minus 1. By the way, there's construction happening. I live in an apartment. The walls are thin, so I'm sorry if you hear a lot of noise. So once you have this set up, what you do is you multiply. So I think that's why Martin over here called it a multiplication table. Because what we're going to do is we're going to multiply like this. So 2x times 2x, that's 4x squared. 2x times negative 1, negative 2x. 2x times negative 1 again here, negative 2x. Then we have negative 1 times negative 1, and that's going to be positive 1. Now, if you remember from last year, cool. If you don't, once you have your box filled out, you can add the two like terms that are on the diagonal of the box. So what we have is going to be 4x squared. And then you have negative 2x plus negative 2x. That's going to give you negative 4x. Then you're remaining with a plus 1. So if I look at what Martin said, he said that if we do this method, we do get 4x squared minus 4x plus 1. We get the same answer that he got. And that does look like that matches to card 4. So according to that work that we did, it looks like 1 does indeed match to card 4, according to what Martin said. I'm just shifting up. I hope you all got this down. Let me just pause here to see if anyone has any questions right now on how we matched 1 through 4. Card 1 through 4. And I'm using the method, first off, all of these things I circled in red, all of these responses, they did the same thing. But I'm using the method that Martin described just because his was more detailed on what to do. I followed his directions. Okay, so then let's go ahead and see what happened though, because I want to see about these answers in purple. So I'm going to go ahead and make this big again so we could talk about that and see what did they do, and then we'll write some work on that. So the answers in purple. So in purple, they matched this card number 4 to card number 2. And what they did is they said they plugged in 1 into the X value leading to 1. And that's what I noticed here. These two here in purple, they said that they matched 4 and 2 because they plugged in 1 and it led to the answer of 1, which is card number 2. Let's go ahead and test their method and see if that's also true, because what if maybe there's more than one match? So I'm going to go to the side and I'm going to copy the method they said to do. So let's try to plug in 1 for X. So notice when I'm plugging in, I just make sure I use parentheses. So I'm going to simplify. So 1 squared is 1. 1 times 4 is 4. Minus 4 times 1 is 4. And then you got plus 1. So we have 4. Yes, you want to copy this down in your notes, because your homework today, you will be matching up equivalent expressions. You want to make sure you have this down. And then sometimes I might be having you turn in the notes. Today might be that time. So just always copy down your notes. So we have 4 minus 4, that's 0. So we're left over with 1. So actually, the people in purple, they're correct. I mean, it's true. When I plug in 1, I do get 1. So it makes sense why they matched up card 4 to card 2, right? But then I have a question for these two folks who said that. Like, does it work for every X? So it works great for 1. But does it work, let's say, if I plug in 2? If I plug in 2 for X, will I still get the output of 1? You all can go ahead and answer that question in the chat. So if I plug in 2 right here, is that going to give me an output of 1? Will that still match up to card number 2? And let's go ahead and put that in the chat. What do you think? Yes or no? Will that give me 1 again? Okay, so I'm getting 2 no's so far in the chat. KK says no. Julio says no. Awesome. So far, we're getting no, no, right? So if you actually evaluate this, right, you're going to get something that's not 1. I could already see this is not going to give me 1. Give me some bigger number, right? So it can't be that card 4 matches to card 2 because not always will this give you an output of 1. It works only when you plug in 1. It doesn't work though if you plug in something like 2 or 3 or something like that. So that's why these two do not match up. Um, awesome. So then that's the example of how to match these up. So that's why these two don't go. Now, if you want to know why this one actually matches to 2, because now that's what's left over, right? This has to match to this one. The reason for that, some of you actually brought up on the Desmos, is that an algebra skill you have to, or an algebraic thing you have to remember, and a rule, sorry, not a thing. Anything to the 0 power is equal to 1. So that's actually important. Make sure you put that in your notes. So this expression is to the 0 power equals 1. So that's why these two match up. So I'm gonna pause there to see if anyone has any questions, because after this, we're gonna have our exit ticket on the Google quiz. You wanna make sure you complete it for credit. And let me also now try to zoom this out. I don't know how to zoom this out anymore. Oh, there we go. So that's just an overview of it. All right, cool. If there's no questions, I'm just gonna pause here. Make sure you get this down in your notes to use algebra. The next tool you can use to check whether two expressions are equivalent is substitution. We saw that 2 of you did the same technique where you plugged in 1. The only feedback I'll give to y'all is make sure you plug in more than just 1 value to double check that 2 expressions are equal. The last thing that I didn't get to, that nobody mentioned yet, but you can totally use, especially on your homework tonight, is Desmos. So if you use Desmos and you graph both of the graphs on Desmos, and if it gives you the same graph, then the 2 cards are equivalent. If they don't give you the same graph, they cannot be the same. I'll show you in a second how that looks like, but first get this down, the 3 different strategies you can use to check whether 2 expressions are equivalent. All right, y'all, I hope you got the 3 different methods down in your notes. I'm gonna go ahead and show you how to use Desmos to check whether 2 things are equivalent.
Is this gonna be on Google Classroom?
Sorry, repeat the question.
Is this gonna be on Google Classroom? The notes?
What is? Oh, the notes, like our slides.
Yeah.
I think I posted the slides yesterday, and it should be on. Notice how when I graph both of these, they gave me the same graph. That shows to me that they are equivalent, right? Because they're going to give me the same outputs. It means they're equivalent. So that's one way you can show whether 2 cards match up, and you can use this strategy for today's homework and for today's exit ticket if you want. Does anyone have any question on the Desmos strategy? Yeah. So comment I got is Desmos makes it way easier. It is a method. All the methods that you put, as long as you're reasoning and explaining what you did, you are correct. You don't have to be like, know all the technical ways to do it. As long as you choose a method, you make it work. School Gmail. 2, private message me if you still need access. So last time, like about 5 of you private messaged me, and I just sent the link to your Gmail. So if you still need to do that, go ahead and private message me. Also, if you prefer to write out your quiz on a piece of paper, take a picture of it, and then send me it on through email, you can do that, and I'll still give you credit. Whatever way you want to like show me what you did on the exit ticket, it will be fair game. Code is this. Great, 22 of us are in. Awesome. So what I'm going to do next is I'm going to anonymize our names. Again, that's just to make sure that you feel safe participating, but we are all are expected to participate. Anonymize. So now you all have some new names. Okay. So on the first slide there, oh wow, some of you already started putting some answers. Awesome. On the first slide, you're going to be asked to look at the video. So I'm going to play it right now. And you're going to be asked to type what are different measurements that are changing in this video over time. Let me go ahead and play it with us, or you already played it on your own. All right, so in that video, some stuff was changing. Go ahead and write down what was changing. Height, speed, velocity. Okay. Sorry for the noise, y'all. It hurts my head too to be in with the construction. All right, awesome. Oh yeah, and then distance. I'm gonna, yeah. The relationship between, and they want you to look at the height of his waist above the ground in meters. So I'm circling it right now. So what they want you to actually see what's changing is the his waist from the ground, right? And they want you to graph it. Notice what's cool though is when I play this video, look what happens to the graph. You get like this vertical thing that helps you graph over time. And what's cool is that the x-axis is already like numbered in seconds for you. The video is 15 seconds long and it's also stops at 15 seconds above the ground. So that's why a lot of people have these little flat portions on the graph. See Karen, Marjorie, John. Some of us don't have that, and that's okay because this is all open-ended. Some of us are doing dots. So let's take a look at what everyone is doing there. I also want to point out something else I'm noticing. I'm noticing that some graphs, I notice that some graphs start at 0, right? And some graphs right here start at the y-axis being a certain number, right? So for the ones who start at 0, I just want to point out, does his waist start 0 meters above the ground? If it doesn't, then you want to maybe correct the starting point. So notice how some of us are starting here.
My screen, Mr. Don, I have a quick question.
Yes, go ahead.
My screen is not allowing me to turn in my graph. Like I've been done with it, but it just doesn't say share with class or.
So take a look at that graph. I noticed that some of you had certain components of it. For example, like the starting point. That's awesome because the waist obviously has some distance from the ground. There were some moments when his waist was still for a certain amount of time, and then so forth. So that's just in relation to what some of you did versus to what's a correct answer. Again, we're starting this discussion because we're going to hit a new section where we're going to discuss how to model graphs. A notice or a wonder into the chat about what you're looking at right here. And it could be about anything. All right, let's go ahead and open up Notice and Wonders. I notice the beginning thing has two equations in one. I wonder how that's possible. I know, huh? It looks like two equations in one. How is that possible? How do you go from 3 parentheses x plus 5 plus 2 into 3x plus 15 plus 2? That's a great wonder. Another wonder that I got privately are there are two functions combined. Okay, that's a good wonder. Zion said, I wonder if the replaced x in the blue equation with the 3x plus 2 in the red equation. That's true. So if we go on this side, the replaced x right here with the blue equation, or I think we're talking about this way over here. Okay, yeah, replacing x. I like that word. On the left side, the x and the 5 are both multiplied by 3. I got privately. So they think this right here is like the distributive property. So 3x plus 15, okay? They got 2 and 1, yes. Miles said, I wonder what are the different parts of each equation doing? Daniel put, do we write this down? So this right now is a notice and wonder. You do not have to write this part down. Right now we're just jotting down what we're noticing and what we're wondering. All right, next. I notice how they have two equations and combine them. Yes. Another question I got, or another wonder privately, is I wonder how both equations are connected. Yeah, how are they connected? All right, let's keep going yet. If you haven't yet entered in your notice or wonder into the chat, you could do it privately or you could do it publicly. Of course, I prefer publicly so that we can all validate what we're wondering about. And we could also validate validate what questions we have about this, as well as what we're noticing. All right, so those are some good notice and wonderings that we're looking at in the chat. So I'm definitely going to be highlighting words like we're combining functions, we're putting two functions together. Gerardo put in the chat, I wonder if they're connected. Yeah, like are these two functions related in any way? Great. Noticing that they're combining functions. And then some of us are noticing like the processes, like what's being multiplied, what's being added, and so forth. All right, perfect. Let's go ahead and shift into an example. So please go ahead and copy down this visual. So this right here is a visual representation of what's actually happening when we're doing function composition. F of x. That's how you read it. Whenever you see a parentheses after it, you say of. So G of F of x. And then you don't say of when the parentheses is at the end of it, of course. So again, if you take a look at your function machine right here at the bottom, this is what you get as your outcome. You should be getting this function composition. Again, notice how that's taking a function and you're plugging it into another function. In this scenario, f of x is getting plugged into g. You could also notice that happening in the function machine because f of x comes first. So you drop x in here, and then f of x goes into g of x. And your outcome is what we want, which is the function composition, g of f of x. Let me just pause here for any questions, and then we'll have another bullet. You have to do the innermost function first. So we got to first evaluate what is f of 1. That goes first, because if you notice, 1 gets dropped in. That's your input. 1 goes here. So I need to figure out what is f of 1. There's something in the chat. Oh, okay. Perfect, perfect. All right. So when 1 gets plugged into f of x, sorry, can someone in the chat tell me what do I get? So if I plug in 1 into my first function right here, what do I get? Oops. So I want to figure out what is f of 1. What do I get when I plug that in? Let's see our chat. All right, so Danny put we get 11. Let's go ahead and verify that. Let's see if anyone else got that, and if you didn't, or if you have any questions, I'm gonna go ahead and show you. So let's see. So, oh, let's see the chat. All right, someone else got 11. They private messaged me. All right, let's go ahead and check then. Do we actually get 11? A lot of us are saying yes, we get 11. All right, so if I plug in 1 in for f, it looks like this. F of 1 equals, so that means it's going to be 4 times 1 plus 7. All right, 4 times 1 is 4. 4 plus 7 does indeed get me 11. Yes, our answer is 11. Oh, I already showed here. So yeah, we get 11. So then my next step is, instead of writing f of 1 right here, we're going to rewrite it as the output that we got. So when I plugged in 1 into f, I got 11. So now I rewrote my second step as g of 11. Let me check out the chat. Great, so a lot of us got 11, great. So again, step 1, plug into the first inner function. Once you get that output of 11, then our next step, if you look to the left here under example 1, you're gonna rewrite your function. So it's gonna be g of 11 now. Now, in the chat, once we get an output of 11, 11 is gonna get dropped down into the g function now. What do I get when I plug in 11 into g? Oh, okay, so there's a question before I ask that other one. How come it's g of 11 rather than f of 11? A great question. So because what we did is, right now we evaluated f of 1 right here, right? When we evaluated f of 1, we got 11. That means f disappeared because we evaluated it. We still did not take care of g, so we need to keep the g on the outside still, like this. I hope that makes sense. Let me know if that makes sense, Cyan, but okay, kind of. Yeah, so once we evaluated with f, the f should go away once you get that output. That's why the inner part became 11, and now you're going to take 11 and you're going to plug it into the g function, because we didn't use g, so we still need to keep g on the outside. Yeah, and then Sam right there in the chat kind of put his own version of describing what just happened as well. Awesome, awesome. Thank you all. Okay, so now the next part is, so we're only halfway done with this, right? We have g of 11. We still need to evaluate what is g of 11. So if you look here in the function machine, 11 needs to get dropped down and plugged into g. Now I believe somebody already answered it in the chat. They got 118. Let us know if anyone else gets that. Well, it was Danny put 118. We could go ahead and verify if 118 is correct. Let's see. Let's do some of the work here. So that means I got to figure out what g of 11 is. So g, wow, of 11 equals, that means right here I got to plug in 11. So it's going to be 11 squared minus 3. 11 squared is 121. I see some stuff in the chat. And we get minus 3. So yeah, I think 121 minus 3 is indeed 118. Yes, that means at the end of all of this, g of 11 is 118. Great, and then everyone else there in the chat seems to agree. Yep, Miles and everyone. Yes. Oh yeah, the exclamation point, I know, it's like I'm yelling. Awesome. So yeah, so then we're done because we have no more functions left over. There was just 2 functions that we had to plug into. So our answer is 118. We have successfully evaluated g of f of 1 in this case. That was the problem. G of f of 1. Step 1 is color code always. For me, if you don't have color coding, that's fine. But for me, it just helps me see what's happening. Okay, so one thing to notice is we don't have a number for x, right? There's nothing to plug into f. So what we're going to be doing instead is, instead of just plugging in a number here, what we're going to do is, okay, if I plug in x into here, all I get is f of x. So that means I'm going to be plugging in the whole function f of x into g of x. So for this one, I'm not going to get a number as an answer. I'm going to get another function. So that one's going to be interesting, this example here. Yeah, so this is going to be interesting. But don't worry, we'll get some practice on this. Okay, step 1. Even though this looks slightly different from the last example, you still are going to start with the innermost function. The innermost function is f. That's the one with the innermost parentheses. So if you look over here to your graph, or I'm sorry, your function machine, your f of x is 4x plus 7. So what I'm going to do in my next step is I'm going to replace f of x with what it is, 4x plus 7. Y'all see that first step I did there. F of x became 4x plus 7 because, according to the drawing, that is what f of x is.
So basically, you just solve f with the equation instead of plugging it in?
That's correct. Yes. And Danny put, wait, so we're using the same /last equation? Yes, that's correct. We're using the same function machine that we did for the last one, but this time we don't have a 1, right? We're now doing a general function. And I'll pause there. So basically, now the question is, how in the world do I plug in this whole function into g? Because that's what it's telling me to do right here. This is saying 4x plus 7 has to get plugged into my g function. This whole function has to get plugged into g. So basically, this is how we have to think about it. So this is my g function down here. It's x squared minus 3. Instead of x, so let me circle where x is. Instead of x, we need to substitute what f is. F is 4x plus 7. Let me show you how that substitution looks like. Oh. So notice how instead of x, I plugged in the whole function f of x, which was 4x plus 7. Let me just pause here to see if anyone has questions on this step.
How did you plug in f of x if you solved for it already? Wouldn't you be plugging in g for x or?
So if I solved for it already, so for example, in the first one where I plugged in 1 and then I got an output of 11, right, for f. But this one, we have no number that we're plugging into. So we have to actually plug in the whole function f of x into g. So this whole thing. So this whole thing, and I'm circling it over here, has to get plugged into x right here.
Okay, I got it.
Yes, and keep the questions coming because this is, it trips up a lot of us. All right, any other questions? I'll pause here, either in the chat or you can unmute. And the slides are going to be on Google Classroom. Yeah, they're already there actually, yes. I moved them to the top, but they're there. It also has all your future lessons on there. And I also have, I could give this as a recording as well. All right, everybody. So now, after we've reached the third step right here, right? Yeah, and a video would be great. Yes, let me go ahead and I'll make sure that I send the video. I could also send it on Remind as well for this class. Once it's uploaded, again, it's going to take like an hour for it to upload. And by the way, we're going to do more examples. I'm hoping more examples we do, the more it clicks. Okay, but now that we're here, I mean, here you're technically right, but the answer is not fully simplified. So we just need to work on simplifying this, and then we'll be done. Because we already have g of f of x, it's this, but we want to simplify our answer. So how we simplify our answer is, notice there's a square here. Oh, okay, so Danny in the chat put box method, so box method. Yeah, because notice there's a square there. That means you're going to rewrite that as this, right? Because squared means multiply by itself twice. So if you use box method for this, right, what you'd get is this. Let me underline that part. So right here, we use box method, and we get this when you use box method. Let me also type that out right here. Box method. And then I'm going to show you how I did the box method in a second. After you have this simplified to this, all you got to do is combine like terms. The only like terms in this equation are the 49 and the minus 3. So 49 minus 3 is going to give us 46. Yes, yes. And I think that's as far as we can go. I think that's our answer. And there's my box method, everybody. I included this on here just so you could see where I got that part that I just underlined. So there's my box method. Oops. Now let me just pause here for questions. This is our answer. It's finally simplified form right there. And we're going to be doing more examples. But I'm just pausing here.
Wait, hold up. So if you had a number to replace the x,
Mm-hmm.
will we instead use that number?
Yeah, so if you had a number to go in for x, like we did for example 1, then it would be more straightforward. You would plug into the first function, and then you take the output, plug it into the second. Yeah.
Okay, but if we don't have a number, then we'll use the equation in the first box and plug that in for the second box.
That is correct. Yeah. Perfect. I like how you phrased it. You make, the more percentage of that commission you get. So X is the total overall money made at the furniture store. So that's the first step, identifying a variable. Next, f of x equals 0.03x. Now, I'm going to first present this to you, and I want someone in the chat, or you can unmute yourself, to tell us, what does this represent? What is 0.0?
The 3%.
3% of the money made.
Yeah, who said that? Sorry, who said that? I can't identify.
I said 3% of the money that you make, basically what you profit from the overall profit.
Perfect. And who's this? Who's speaking?
This is CJ.
CJ. Awesome. Thank you so much. That is correct. So the 3% commission, right? Yes. Because 0.03 represents the decimal of 3%. Totally. How do you spell commission? There we go. 2 M's. Perfect. Let's write that down. So yeah, this function right here represents the 3% you get on the commission. Perfect. You write that down. Now, oh, didn't get a chance to unmute, but okay, I did. I answered and left. Okay, awesome, y'all. Great. Okay, so we all understood that that was the 3% commission. Perfect. Now we need another function, because not only are you getting 3% commission, but you have to make over $2,000. So we need another function to represent that. This function here, let's say the second function is going to be G. This here represents the X amount you make if you make over 2,000. So for example, let's say I made 3,000. $3,000. If I made 3,000 bucks and I subtract 2,000, well then that means I made $1,000 over the 2,000 mark, right? And then basically this $1,000, if I take the 3% of that, will be my commission. So this function right here represents how much I make if I make over the 2,000, if that makes sense. Making over 2,000 is this function. You have to do x minus 2,000. You could test it out with any x value. So for example, if I made 4,000, let's say I sold $4,000 worth of furniture at the store for x. So that means overall, I'm going to get 3% of 2,000 bucks and so forth. So yeah, you could totally test it out and you can see that this here function will represent your sales over $2,000. So that's just, let me know if anyone has any questions on that G function there. Let me clear this up. And these bottom blue parts are just examples for you to see that that function is valid because I'm testing it out and showing that. Oops, I didn't want to undo everything. Just want to erase the bottom stuff. This one I'm going to put make over 2,000 in sales. Or sell, you know what? That's a better word. Sell over $2,000 of furniture. Sales over 2,000. There we go. Over 2,000. Perfect. Whew, there we go. We got two functions. And let me check the chat here. Can you repeat that step again? Which step? Sorry about that. Which step in particular? Let me know. So the first step was we had to create a function that represents 3% commission. That's going to be 0.03x. 0.03 is the decimal version of 3%. Whenever you're dealing with percentages and math, you want to convert that to decimal. This second function right here represents sales over 2,000. So what we did right now in the steps is basically created our two functions. And previously what I did is I substituted like made up numbers for X to check if that did actually give me sales over 2,000. If I made $5,000 in sales, I do 5,000 minus 2,000, that gives me 3,000 that I made over the 2,000, and that would be the commission that I get the 3% on. So that's just me just verbally going over the steps I did. Let me know if I need to write down something again or something there in the chat. All right. Now that I have these two functions set, okay, that's great. My goal is I want to create a new function that's going to tell me how much I get money in my pocket. So that's what I want to know. Like, I don't want to like know these two separate things unless it's useful to me. For example, I wonder which one will be more useful to me if I do f of g or g of f. So remember, the function that's in the inside, either g or either f, whatever's on the inside means it has to happen first. So which one needs to happen first, the 3% commission or making sales over 2,000? Let's see what the chat says. Shouldn't G goes first? First one, sales first. And then Risha says the 3% commission. Sam says sales first. I wonder if for those who are saying sales first, can you give us like a reason? Maybe unmute or you could type it. Why do you think the sales should go
first? Because you don't get the commission on the sales. You need the sales first or else the commission doesn't matter.
Yes, and I'm doing the wave here. Yes, you do need to, like, in order for you to get the commission, you need to make the money first. You need to make the sales first. So the sales comes first. So that's correct. The function we want, let me just let people in, is this one. Let me circle it. Let me also change the color. Too much blue now. Nope, I don't want red. Purple. This is the one we want, right? Because you only get the 3% commission if you first make over $2,000. So we don't want this one. So see how the order here will matter when you're setting these up and creating your functions. So yeah, we don't want that. Let me know if anyone else has any questions on that, but it was nicely explained there. All right, so then if we need f of g of x, let's go ahead and start to build that function that's going to tell us how much money we get in our pocket. All right, and some of my drawings are in the way, so I'm going to have to erase what I circled here. But we're doing this one. All right, so f of g of x. So the next step is going to be g of x is on the inside. That means I'm going to replace g of x with what g of x is. It's x minus $2,000. So see, that's my next step. All I did is I rewrote g of x with what it is, x minus 2,000. That's that step. And what this is going to tell me here is that I need to take this whole function and I have to plug it into f. That's what this is telling me to do. So what this is telling me to do is I need to take this whole function, because g is going into f. This whole function needs to get plugged in right here where the x is. Needs to get substituted like this. You're going to replace that red x right there with the blue. That's what we're going to do in the next step. Let me show you what that looks like. There we go. See, notice it's 0.03, but instead of x, it's the g function, the x minus 2,000. Let me pause here. Yeah, Danny, it's exactly that. Sorry, I didn't see the chat before you, I saw the chat there, but I didn't click on the chat. Perfect, so this is our setup. This is basically the answer, everyone, but it's not fully simplified. We want to make sure we simplify. What should I do next to simplify this fully? And this one, I'll wait for the chat. Multiply or distribution? Yes. All we got to do is, yep, Risha, totally correct. We're going to distribute. Let's do that. So 0.03 is going to get multiplied here to x, and 0.03 needs to get multiplied to $2,000. You could totally use a calculator for that part, the 2,000, but this one's going to become 0.03x minus 60. So if you use you could use your phone. If you do 0.03 times 2,000, you're going to get 60 as your answer. So this right here looks like it's fully simplified. There's no more like terms I can add. So this looks like it's our new function. This is going to represent the total money that actually goes into our pocket. I'll test it out and you'll see. So there we go. This bottom part is just kind of synthesizing what we did. This f of g of x, our new function, represents the total money that you get in your pocket if your company makes over 2,000. Try substituting for x and check. So we could try different numbers. Like let's say, yeah, you could write that, Danny. Yeah, this is like the synthesis. I would totally recommend y'all to write this down, the bottom part, and then I'll go ahead and test out my new function. So let's see. Let's say I make 10,000 bucks. I'm going to circle my new function here. This is my new function. Now, if I make 10,000 overall sales in the furniture store, all I got to do is I'm going to plug it in here. So 0.03 times 10,000. Let's say I make 10,000 because, you know, furniture is expensive. I bet it'd be easy to make like 10,000 in a furniture store minus 60. Again, I'm using this down here, the new function. Using my handy dandy calculator on my phone here, I'm going to do 0.03 times 10,000. Then I have to subtract 60. So if my furniture, if I sell $10,000 in furniture in my store, the commission I get is only 240. Not that much, to be quite honest. 3%. So if you do the math on your phone, you'll see that. And you could test it out. Let's say if I make 20,000, I don't know, maybe it's much more, you get much more if you sell an overall of 20,000 in furniture. Try this one. Let's see what's worth our time. So if you were like working at a store that did something like this, you could kind of test like, hey, is it worth the commission? Or like if I sell a certain amount, how much am I going to get? Times 0.03. So if you oops, no, I messed up. Times 20,000. Darn it. Minus 60, 540. So if I sell 20,000 in furniture, I would get 540. I guess you would have to it depends what you're selling there in the store. Hopefully it's the fancy expensive furniture, because the more expensive it is, the more you sell, the more money you'll get in commission in addition to your weekly pay. So some stores work like that. I know in Macy's, sometimes they hire people like salespeople based on commission and composition. As a group, you're going to reach an agreement. Just whatever agreement it is, it doesn't have to be right. It's about participation here and just getting your ideas down. When I come by, I should see that the screen is being shared by someone in the group. You all can decide among you, like maybe you could do earliest birthday or latest birthday. I don't know, like just decide who's going to do it and just make that a quick decision.
Teacher joined. You could ask her to send it to you.
Mr. Donald, can you read the equation? I forgot to take a picture of it. Like, is it how?
Oh, we got the equation. Do you still need the link or no?
Oh no, I have the link for the drawing thing. I'm on it right now.
Okay, I can read you the equation we like.
Okay.
So can Sam.
Okay.
There's g of x.
Horrible, Mrs. Sedano. I can't write. There, forgive it.
Okay.
Give 10,000 minus 5,000.
Mm-hmm.
So that it would equal 5,000, right?
Yeah, and then you can multiply it by 0.1, and I think that's your answer.
Mm-hmm.
Multiply? Why would you multiply it?
Because
it's the same thing as dividing, but it's just better, and that's what they're asking for.
Okay.
Divided by, well, I cannot write.
He said multiply by 0.1.
Multiply
0.01. Or you can just divide by 100. It's the same thing.
I was going to put divide anyway. Good.
I know how hard it is for me to draw on those. Yeah. It's very hard.
Right, and then you should get 50.
But AJ, the link isn't working.
It's not working.
Mm-mm.
Miss Sedano. Oh yeah, she got it.
Thank you.
Yeah, that doesn't work.
Did Clinton leave the group chat?
Oh yeah. Oof.
Why?
I don't
I
know.
don't think he likes us.
Probably has some technical issues, actually. It happens with him.
Yeah, it's all good.
Okay.
Yeah.
Okay. So okay, this is what I'm doing. Okay,
Bro,
this
somebody else looked way worse, bro. Like I couldn't.
What?
Remember, like when I share my screen, like the first person.
this is a commission, right?
Yeah.
Yeah.
Okay. Okay, yeah, commission. And then
That's
this,
CeeLo?
Ooh. Yep, yep, yep. You got it. You got it. Okay, this is the other part. Oh shoot. Okay. 5,000. Yep, yep, yep. Okay. Then we're using this one. I don't know why, but we just are. Okay.
I don't think that's right. Miss Donald's face look weird. Is she seeing that?
Well,
It's right, but I want to know if anyone in this group knows why f of g of x would be right to use here.
I don't know. My phone died, so I couldn't really understand it. Without the sales, you can't get like the commission.
Yeah. Perfect, because you got to make the over 5,000K first. So you got to do G first, right? Then you get your commission. Perfect.
Yep, yep.
Awesome job, y'all.
Oh my God,
That's my little
I'm gonna actually bring us together in a sec. I might use your group's example. We're almost out of time. All right, group. They went ahead and they wrote down the g of x, f of x, and they had the it's gone. There it is. They had the correct setup, f of g of x, and then I asked the group why the setup was correct. So the group was like, I think this is correct. I don't know why. But why is it important that g of x goes in the inside here for this particular problem? Can someone unmute or in the chat? Why does
Sure, I guess I'll do it.
Awesome.
Just like the other equation,
Awesome.
Just like the other equation, the 0.10x, it doesn't matter until the x minus 5,000 occurs.
What was that again? Repeat that. Sorry.
I want to look back at the equation real quick. Just like in the last problem, you didn't get the extra profit unless you made that money first. And you need to make the 5,000 first, or else you wouldn't get any bonus.
Yes, that's correct. So this is the correct setup, f of g of x, because g here represents first you are getting the commission. You got to get the money first in order for you to then take 1% of that